Alright, before we go on to the next section, we gotta go ahead and make sure that we know the differences between these certain things. Remember how we learned about AROC and IROC? So let's go back to that. AROC versus IROC. Maybe I need to put some good paper on here, so that's what we're gonna call it, AROC versus IROC. Now, AROC, average rate of change, it's an average of the number. For instance, if I tell you that I drove 50 miles per hour on average, that doesn't mean that I drove 50 miles per hour the entire time. It just is saying that I drove 50 miles per hour on average starting on this time to that time. IROC, instantaneous rate of change, that means at that point. So if I were to ask you what's my velocity at that point, you're gonna have to take the derivative of something and tell me at that point. So for example, if I were to give you, okay, so my position function, x of t, is 3x squared, right? And I tell you, okay, what is my speed at 2 seconds? That means I have to take the derivative of this, which gives my velocity 6. Well, I apologize. That should be t. 3t squared, which is 6t. At 2 seconds, I was moving 12 miles per hour. However, if I ask you for the average, so same example, and I'm going to ask you, what was my average velocity? So my position is still this, but what was my average velocity from time equals 0 to 2, right? That means I need to know where I'm looking at the slope from 0 to 2 of the position. So let's take a look at that. So this time we're not taking the derivative. We actually have to look at the slope. You have to look at the actual slope, rise over run, y2 minus y1 over x2 minus x1 of the position. So this time we have to do position at 2, or y2, minus y1 over x2 minus x1. So this is what I mean. That one represents y2, this is my y1, this is my x2 and x1. From now on, my f of x, remember how we have f of x is y? From like pre-algebra, same thing. Instead of f, I'm using x's. So in this case, I'll have to do, okay, so my x at 2 was this. Oops, I apologize. Minus this pen is just not working with me today, over 2, okay, which gives us 12 minus 0 over 2, okay, and this is telling me my average speed was 6 miles per hour, okay. Do you all see the difference between those two? If I were to ask you for the average velocity, that means I need you to take actual slope, like y2 minus y1 over x2 minus x1, to do algebra for me whenever it says average velocity. So, yes, on both of these cases, you are still going from, on both these cases, you're going from position to velocity. That's what you're doing. Or velocity to acceleration. However, position velocity or velocity to acceleration. However, if I ask for the average velocity, so if I'm asking for the average velocity, then I need to do the y2 minus y1, algebra 1 on this. But if I were to ask you, what is it saying? But if I were to ask you for instantaneous rate of change or velocity at that point, I have to do the derivative calculus on it from on my p. Does that make sense? Because to get to velocity, to get to average velocity, I have to come from position to velocity, because that's what velocity is, slope of position. Good? Now, if I were to ask you for vice versa, what if I asked you for, if I were to ask you for average acceleration, right? From point A to B. Then I know, since it's average acceleration, this automatically means that it's algebra 1. I know this. I have to do y2 minus y1 over x2 minus x1. I know that. But in this case, I want acceleration, and I can't come from position. Acceleration comes from taking the derivative of velocity. So I'm doing the average velocity, which will give us the acceleration. So I'll do v velocity at b. So this is my y2 minus y1 over x2 minus x1. And I know this is confusing because it's in this bracket notation, but this represents your x's. This is your x1 and this is your x2. Okay, so this will give us average acceleration because we took the slope, because this was our slope, actual slope, y2 minus y1 over x2 minus x1 of velocity. Average acceleration is slope of velocity. However, if I were to ask you for what is my acceleration at time equal 4, I'll actually have to take the derivative of the velocity and plug in 4 to it. Whatever my velocity is, I'm taking the derivative of it and I'm plugging 4 into it. So I hope that made sense. If it didn't, I hope I can make sense out of that sooner or later, because it's very, very, very important. AROC, average rate of change, is algebra 1. IROC, instantaneous rate of change, is calculus. AROC, but both of them are slopes. So you're going from position to velocity or velocity to acceleration. Does that make, are we okay? I hope so.